Hello, hello, hello everybody, and welcome back, welcome back. We're looking at question 22 in this video on our grade 9 multiple choice Pascal paper. Rhombus PQRS is inscribed in rectangle JKLM. Oh, this is quite the diagram we've got going on here. A rhombus is a quadrilateral with 4 equal side lengths, but they don't have to make right angles with each other. Okay? That's the nice thing. They're like squares if you just sort of bent a square a little bit out of shape. Now that looks too much like a square, but you get sort of these diamond shapes. Again, I can't seem to help drawing a square. Let's make it really obvious. There we go. So that would be a rhombus if all 4 sides are the same. Okay? I don't need the... You get a square when it's a rhombus with right angles. That's all. Segment PZ and XR are parallel to JM. Okay, where did Z come from? Segments QW and SY are parallel to JK. Okay, so these are parallel to the sides of my rectangle, which means they will form right angles with one another. It's kind of nifty. Okay, if JP is 39, JS is 52, and KQ is 25, what is the perimeter of rectangle WXYZ? Okay, they even tell me it's a rectangle, but I figured it out on my own, so that's fine. That these were right angles. Anyway, okay. So let's copy our picture down and try and make sense of what's going on. So we have some rectangle, and inside we have a rhombus. So all these lengths here are going to be the same. And we've got 39 here, I think it was 52 here, and 25 here. Although, admittedly, it really does not look like that in my picture, so I'm going to redraw my picture slightly. But I think we're going to see a lot of congruent and possibly even right-angled triangles. So let's try and make this look a bit more natural. Okay, that's a little better. This is definitely a longer side. Okay, and then we have perpendiculars there, and we get a really tiny W, X, Y, Z. But that's fine. Your pictures don't have to match their pictures, although their provided picture is usually the best thing to mock up when you're writing the actual exam, because they give you a little booklet with it, but I like using my rough paper. But you notice, because we got a rectangle, we have a bunch of right angles here. Just a ton of right angles. So 39 and 52 in, let's get some colors out of here, this purple triangle. Well, we got their legs of a right angle triangle, so I can figure out, well, 39 squared plus 52 squared. Let's bring in the letters. So it's J, K, L, M, P. No, that was S. That was S. So P, Q, R, S, and then W, X, Y, Z. So this should be PS squared, the hypotenuse. Now you can grab your calculator and compute them, or I would notice that this is 3 times 13, 4 times 13. So this is really just a 3, 4, 5 triangle, and we're going to have 5 times 13 squared be PS. PS is just going to be 5 times 13, or 65. Now because it's a rhombus, let's get another color out here, orange. Because we've got a rhombus here, these orange lengths are the same. Okay, what can we do with that? Well, I've got this KQ over here is 52. Or sorry, not 52, 25. So we got a 65 here. I guess I could figure out PK. I don't quite know how that's going to help me right now, but I could certainly do it. PK squared will be 65 squared minus 25 squared. And I noticed that that's 13 times 5 squared minus 5 times 5 squared. This is a 5, 12, 13 triangle, so PK squared is going to be 12 times 5 squared. PK is going to be 60. All right, so we've got 60 there. Now, do we have any other information here? Just those three lengths. I've used the fact that it's a rhombus. We've got these parallel sides. Parallel sides, so that means JS. Let's get some green going here. JS has got to be the same as PZ, so that's also 52. And we got 25 here. Carries over to a 25 here. Oh. Wait a minute. There's no way it's that easy. 25 here means a 25 here. A 52 here means a 52 here. Yeah, it's just a... Oh. Okay, none of this was necessary. It's okay. Experimentation happens. Oh, wait. Maybe it might be yes, it was necessary. Oh, silly me. I erased it all. It was necessary because this is going to get... It's not a square. I started crossing this out because I thought it was a square. But this WZ is going to be 52 minus 25. And so will XY. So 52 minus 25 is going to be 27. But now, running out of colors here, WX and ZY are the same, and they are 60 for the total length there, minus... well, I guess this has to be 39. Wait a minute. I need another length. So I've got 60. I need to cut it off. So if I knew this length down here, we'd be all set. So I still have some more work to do. It's a very interesting diagram. Alright, so what can we do here? Got 60, I've got 39, I got 52, I got 25. I feel like this length down here is going to be 39, but I can't guarantee that right now with the information I've got. Well, let's take a look here. So, this angle and this angle add up to 90 degrees. This angle and this angle must add up to 90 degrees. What I'd really like to do is show that this has the same angles as JPS. I can't currently conceive of a way to do that. Alright, if it's a rhombus, this angle at S is going to be the same as this angle at Q. I think I need to draw my picture again. It's a very, very messy diagram. And I feel like this is... I'm missing something. The Pascal 22 shouldn't be taking me this long, just based off experience. So 65, this is 52, this is 39, this is 39, this is 25, this is 60. I was able to figure out that this is 27, this length here. But it doesn't help me because it's not a square, which is a shame. I really feel like this is 52, this length here, but I can't prove that. And while on a grade 9 contest, people will probably use that without thinking, and it probably is true, I can't in good conscience do it without proving it. So I'm going to leave it as is. So 39, and then plus whatever, we'll call this x. X is what I'm missing. So we got 60 minus x here. And a 65, and this is 60 minus x, and this is 39 plus x on this side. This is 27, and we got a 65 here. So I suppose I could set up an equation that 65 squared minus 60 minus x squared, which would be this length squared, is equal to 65 squared minus 39 plus x squared. So if I square root both sides, their difference is 27. I don't like this expression, but it will give me x. Okay. And I'm betting that it's going to just be 21, which is the difference between 60 and 39, but can't currently prove it. So square both sides, we'll get 65 squared minus 60 minus x squared is going to be 65 squared minus 39 plus x squared plus 27 squared plus 54 squared. I'm not happy with this. I'm not happy with this at all. I don't particularly want to go this way. Well, let me grab my calculator and see if my hunch of 21 working is correct. So 65 squared minus, so if it were 21, we'd have 60 minus 21. 60 minus 20 is 40, so we'd have 39. So minus 39 squared. And I square root that. I get 52, so I think 52 over here. Adding 21 to 39, I'd get 65 squared minus 60 squared. And that would be, square rooting that would be 25. And if I add 27, then, okay, hurrah, it works out. So x has to be 21. But again, I am really, really not happy with that. I want to be able to show that this has to be the same as 39. I'm guessing there's a symmetry argument to be made, or some sort of angle argument to be made, and I want to make it. 21 is the answer. Not 21. We want they want the perimeter, right? They want the perimeter. So it would be 21 plus 27 plus 21 plus 27. So 2/48, that would be 96. 96 is the perimeter. So if you're not interested in me figuring out where my problem is, the answer is D, and you can move on. But I want to take another crack at this because I am not happy with how I'm doing the question. And when you're doing a contest, this can happen. As long as you get the answer, continue on. Don't waste your time making yourself happy as long as you have something that you know will work. But it's definitely something that can drive you after the fact on the contest to try and do better or make your answers faster. And that's sort of what I'm doing right now. Alright, so this should be enough. In a rhombus, this and this are the same. Opposite angles are the same in a rhombus. Fine. Okay, so I've got this, 90 minus this. And then, let's call it orange. So orange plus blue plus green is 180 degrees. The red dot is actually 180 minus the blue dot, so we can actually get rid of the red dot here. Incidentally, how do I know this? How do I know that these sides are opposite? Well, if you connect the sides, because it's a rhombus, you get isosceles triangles, and since they share a side length, they must be congruent. So that's how you know opposite sides in a rhombus are equal. But I don't want to use that fact right now. And since the angles inside a quadrilateral have to add up to 360, that's how I know it's going to have to be 180 minus the blue dot here. Okay, but 180 minus the blue dot is green dot plus orange dot, because they form a line over here. So I'm going to have green dot plus blue dot in the corner here. So I got 90 minus green dot. Well, that's, if I add on green dot, I get 90 minus orange dot left over. And so that means, so if I got 90 minus orange dot, then I need orange dot plus 90 to make the full 180. No, 90 minus orange dot. And that puts orange dot here. We've got 90 minus orange dot here. Similarly, must have 90 minus green dot here and green dot here. And now these guys are congruent, just as I suspected. So 39 here, 39 here, and the 60 up here. Now they get to sort of cancel out and get the 21 here that we wanted. All right, now I'm much happier. So if you stuck with me, there we go, angles saved the day. And that was a really cluttered picture. I was having a difficult time keeping track of everything that was going on there. But you'll notice only at the end here did I add in those extra parallel lines to make the rectangle, because I was really just interested in some congruent triangles. Okay? But as I already mentioned, you can, and most people at a grade 9 level are not worrying about, is this completely rigorous? Do I have all my ducks in a row? You get a number that satisfies the equation. As long as you have faith in the equation, you just move on. So yeah, the answer is D, it's 21, but now I, as a mathematician, am satisfied because I didn't just follow a hunch. Okay, following a hunch is not usually what you want to do, especially if you're going to do written contests, because you can't just say, well, this probably works out, or I'm pretty sure the details will work out, because you get marked on the details. Okay, and so maybe I have just too much of a written contest mindset, but well, I'm glad I stuck around and fixed it all out. I'm satisfied, at least. Okay, so that was question 22. Up next will be question number 23. I hope to see you there.